My name is Chris Holdgraf. I work at UC Berkeley with the Jupyter team, working on projects that apply Jupyter technology to research and education. And I'm also helping bootstrap a new nonprofit organization that I'm here to talk to you today about called the International Interactive Computing Collaboration, or 2I2C. So 2I2C focuses on interactive computing and workflows with interactive computing and data analysis and research and education. Why do we think that interactive computing is a really important and powerful piece of the research and education community? Well, over the last couple of years, the founding team of 2I2C has worked on several projects, and I'm just going to talk about a couple of interesting ones of note today. So first off is applying interactive computing to facilitate large-scale research in the earth sciences. As some of you may have heard before, the Pangeo project is a really interesting community combination of sort of technology, cloud infrastructure, and domain use cases in the earth sciences for geospatial analytics in the cloud. It has a focus on allowing scientists to access resources that they would not otherwise be able to access, to provide rapid feedback for iteration and exploration that utilizes those resources, and that uses this technology to allow researchers to tell compelling narratives that are backed by both computation and analysis. And as one example of just this, I want to show you the kinds of things that the Pangeo project deploys. So in this case, we're looking at someone displaying a raster image in a map context. And what the researcher can do is zoom in on that image, and the image immediately updates itself in order to show this new resolution that the researcher has zoomed in on. Now at the bottom, you can see a Dask graph that shows off a few different computations that are happening. I'll click this again just so that you can see this again. And what I want you to notice is that when that zoom happens, a lot of different tasks are activated automatically. And effectively what this is doing is utilizing a scalable Kubernetes cluster in the cloud to on-the-fly recompute the resolution needed to view this image. And I think this is really interesting because it basically gives you Google Maps-like immediate feedback and an idea of what you're trying to look at. But what it's doing is utilizing a fairly complex set of infrastructure in the cloud, as well as scientific analyses that allow the researcher to explore their data in a much more efficient and rapid manner than they would otherwise be able to do so. So underneath this Pangeo stack is a collection of open source tools and open source infrastructure that includes tools like scikit-learn, Xarray, and Dask, and the PyData ecosystem, along with the Jupyter ecosystem, kind of tying it all together and providing that interactive window that users have access to. And this stack allows, an individual sitting in a coffee shop on their laptop to be able to access both really large data sets stored in the cloud, as well as non-trivial and scalable computing resources that are also stored in the cloud. Another interesting use case for interactive computing is in teaching and education. And a lot of this comes from our recent experiences at UC Berkeley through deploying infrastructure for a course called Data 8. So the goal of Data 8 is to provide a shared computing environment for all of the students as well as the teachers and instructional staff. This allows us to structure the content of the course in a way that makes assumptions about the infrastructure students have available to them. And that allows us to accelerate the students through the course, especially the ones that are less familiar with computation and data analytics and computer science. We can provide shared infrastructure in the cloud that reduces many of the hurdles that would otherwise make it more difficult for them to participate. And as a result of this, Data 8 at UC Berkeley has been an incredible success over the last couple of years. At the bottom here, I'm showing, I think this is actually 2 or 3 years old now, but the first day of course of the course for the semester, you can see they have an entire auditorium packed with students. And importantly, these aren't just computer science or mathematics or statistics students. They're from across the entire range of the student population at UC Berkeley. And so Data 8 uses this integrated combination of multiple kinds of infrastructure. It uses Jupyter Book for its textbooks. It uses JupyterHub for its online cloud infrastructure and data science environments. And it weaves all of these things together to form a sort of coherent pattern of technology throughout the semester of the course. And similar to Pangeo, the JupyterHub and the cloud infrastructure deployments of Data 8 also utilize this PyData, Python-focused ecosystem, providing a variety of different resources, but also including infrastructure in the cloud deployments for things like grading and other kinds of course infrastructure. It uses university authentication so that each student has their own personal identity on that cluster. And it utilizes exterior resources like GitHub in order to host the actual course content. So what students see is often a rendered Jupyter book or a website that contains the materials for a given week. But underneath that content is a Jupyter notebook that exists in a GitHub repository. And then there are a collection of connections made between the JupyterHub that all the students have access to and the course content that holds the actual homeworks and weekly readings and things like that. And then finally, I want to note that both of these things are particularly interesting, not only for their specific use cases, but also because they provide the potential for a much broader, distributed, and more inclusive access to these technologies. And for that, I want to highlight two other projects that have been going on over the last few years. The first one is the Syzygy project, and this has been led through the Pacific Institute for Mathematical Sciences. Syzygy is effectively a collection of federated Jupyter hubs across Canada. So it is hosted from PIMS, which is primarily based out of the University of British Columbia, although PIMS is actually serving a collection of universities across the country. And via the Syzygy project, PIMS is providing Jupyter hubs, almost lightweight Jupyter hubs as a service for over 20 different Canadian institutions across the country. And each one of these things is serving both educational use cases, in some cases research use cases, and it's running on Canadian infrastructure. But all of that infrastructure is managed by PIMS, which removes a lot of the challenges in deploying this kind of technology for your courses or for your research teams. The other thing that I want to talk about is the Binder project. So this is a derivative of JupyterHub. It's basically a project that relies heavily on a JupyterHub in order to focus more around shareable, reproducible interactive computing environments. And as a part of this project, the Binder team runs one large Binder hub deployment at mybinder.org. Over the last couple of years, that deployment has grown considerably. And to this point, mybinder.org serves over around 100,000 users each week. And importantly, and I'm showing that here in this figure to the right, those usage patterns come from all across the world. Basically, every single country in the world is now covered by the usage at mybinder.org. And I think this is really interesting because, again, it's providing access to online computational resources that would otherwise be much more difficult for students to have access to. They no longer need to have their own laptop with a well-crafted setup environment that works on their machine. All they need to do is go to mybinder.org and they can have access to a variety of different computational environments for whatever it is that they're trying to do, whether it's research or learning. So one of the things that we've noticed over the last couple of years, and after having run a number of different tutorials and trainings and boot camps around this infrastructure, is that these successes are actually pretty difficult to replicate. It's possible at universities like UBC or UC Berkeley, or a well-funded research project like Pangeo, but it's actually quite difficult for these projects to work outside of those contexts. And I think a lot of this comes down to one fact, which is just that cloud infrastructure requires expertise to run. And in particular, this is expertise that is often rare inside of a university or a community college context. And it's also a very in-demand skill set that a lot of other entities are trying to gobble up and attract as well. So deploying all of this infrastructure, understanding the different pieces and how they all come together is a really challenging part of deploying something like a JupyterHub for research and education. You have a variety of choices, both on the open source data science side of things. For example, how do I most effectively apply NumPy and Pandas and scikit-learn to this research problem or to this educational problem? But also on the cloud infrastructure side, like how do I orchestrate a Kubernetes cluster to effectively provide this infrastructure for my course? And I think that has become a real barrier towards seeing the growth and the adoption of these tools across the research and the educational community. There are a lot of vendored solutions out there. Most of the cloud organizations and a number of smaller startups offer various vendor and proprietary software as a service, where basically students will just go to a website, they'll log in, and they'll get back some kind of interactive computing environment in return. And this exists both in the educational space and in the research space. These are often more polished from a user experience standpoint, and they also have a more well-developed sales wing to reach out to universities. but they also often tend to use proprietary interfaces, proprietary infrastructure, vendor-specific APIs and formats. And effectively, they make it more difficult for researchers and educators and institutions in this space to flexibly move between cloud providers or between different types of infrastructure. And moreover, these kinds of services usually aren't tailored directly for research and education. They're often tailored for things like the machine learning community or the business analytics community, and we're kind of piggybacking on top of that from research and education. So we think that all of this is a big problem, because we think that it's really important that educational institutions, that research institutions have maximal flexibility and choice over where their infrastructure lies. This is particularly important in research questions where you don't necessarily know where your data sets are going to exist. And you need to have infrastructure for interactive computing, for data analytics, for data science that is vendor agnostic, so that it runs the exact same way across all of those different infrastructure and cloud service options that are out there. So for this reason, we don't think that the research and education community can rely on these kind of vendored solutions or proprietary solutions to solve these problems in the long term. So as a result of that, the 2I2C founders have this really strong belief, which is that organizations in research and education need access to cloud infrastructure without hiring full-time engineers. They need to be able to leverage the cloud and to utilize the cloud without hiring their own full-time DevOps staff. Because if we require that of these institutions, this technology is just not going to be adopted at an institutional level across the world, because it takes too much resources and too much effort to do so in a reliable and a scalable way. Another point that I want to bring up is that over the last couple of years, we've all seen the Jupyter ecosystem grow in its use and in its adoption. But it's worth noting that a lot of that adoption has been at the individual level, and that the amount of resources flowing into the Jupyter project has not scaled with the rate of growth of the project at large. So here I'm showing, it's actually significantly higher than this now, but Peter Parente runs a notebook that occasionally analyzes how many IPyNB files or Jupyter notebooks exist on the public repositories in GitHub. And a couple of months ago, we saw that number first hit 5 million public Jupyter notebooks. So you can see that Jupyter notebooks are starting to grow in this kind of exponential way across GitHub and across a variety of other platforms as well. But one of the challenges that this brings with it is that now Jupyter also is steward over a variety of GitHub repositories that have fairly complex code bases, and they're used by many, many, many people, even though it doesn't have a reliable set of resources to maintain and sustain and develop and also grow both those code repositories as well as the communities around them. We believe that this is in particular a challenge from the research and education community, because over time we've seen the contributions within Jupyter come more and more and more from the business community and the private sector, and less from the academic community, from the research community, and from the education community. And there's not an inherent problem with that, but we believe that it's important for the parts of Jupyter that represent research and education to be strong and to be sustainable and to be a consistent source of input into the Jupyter ecosystem, to make sure that Jupyter continues to represent the interests and the needs of research and education. So we believe that underlying this cloud infrastructure, particularly the pieces for interactive computing, are open source tools that actually need more support. Even though it seems that a lot of these tools are well resourced, they often really could use more organizations giving back and contributing resources to developing new features, to growing communities, than what we currently have. So all in all, we think that 2I2C thinks that the research and education community needs tools that are available without the requirement of DevOps, but that provide infrastructure that leverages the cloud and that provides really powerful interactive computing environments for data analysis and for interactive workflows. We think that those cloud environments need to be compatible with institutional procurement, so that universities can just pay for these things and get a cloud service in return, but in a way that is completely vendor agnostic as well as infrastructure agnostic. So there's no point at which you're actually locking someone into a service. You're just providing an opinionated, deployed set of open source technology that happens to run on one particular cloud vendor, but that could run on any other one if that's what the university wanted. And then importantly, also gives the university the freedom to take control entirely of that hardware stack and that infrastructure stack if they wanted to maintain it themselves and move into a new direction. We also want that infrastructure to be both sustainable as well as reliable. So it needs to be able to generate revenue. It needs to be able to pay people for people's engineering time, for careers. It needs to have a growth plan and a sustainability plan. But it also needs to have a plan for giving back and contributing its resources back into the open source community so that those open tools and the communities behind those tools that underlie this infrastructure are well supported and have opportunities to grow and thrive as well. So with that, I want to mention this new initiative that we've started in the last couple of months called the International Interactive Computing Collaboration, or 2I2C. 2I2C is a young organization still in its bootstrap phase, but it's a nonprofit, mission-driven organization with the goal of supporting primarily the research and education community via interactive computing infrastructure. It wants to be a service provider for providing this infrastructure on cloud resources, but again, with the option of running this kind of thing on your own local resources as well. It also wants to be a collaborator for research and educators that want to access development in this space of interactive computing and open source technology applied to their research projects or applied to their educational initiatives. And then, as I mentioned before, we also want 2I2C to be a key collaborator and contributor to all of the open source tools that it uses as a part of its stack and its deployments. Behind 2I2C is a team with many years of experience in interactive computing, specifically in the cases of research and education. And really our passion that kind of shares us all, that joins us all together, is that we want to make interactive computing both accessible and scalable for the broader research and educational community. We want to do that by providing support and development for open source tools and communities underlying this infrastructure so that we can more effectively deploy this infrastructure for partners in the research and educational community. As I mentioned before, there are basically three different pillars that make up 2I2C. One of them is providing managed infrastructure in the cloud. One of them is providing research and development for that infrastructure in more sort of bespoke and hands-on applications in research and education. And finally, we want to have an explicit aim to support the open source communities that we utilize as a part of the various cloud deployments that we have and that we think are particularly useful for the research and the educational community. The founding team of 2I2C is made up of leaders from a number of projects that have applied interactive computing and infrastructure to use cases in research and education. Ryan Abernathy is one of the leaders of Pangeo. Catherine Carson, myself, Yuvi Panda, Lindsay Higi, and Fernando Perez have all been involved at UC Berkeley, both with the Data Science Education Program and the JupyterHub, as well as with the Jupyter project more broadly. And Jim Colliander is one of the leaders of the Syzygy project for Federated Canadian JupyterHubs. So across all of these different use cases, we think that we have the right kind of experience to both understand the open source technology, the open source communities behind that technology, and the challenges that that presents, as well as the ways that this technology can be particularly useful in deployments for research and education. So as you can probably guess, the infrastructure stack that we're going to try and deploy as a part of 2I2C is primarily made up of tools in the Jupyter ecosystem, as well as the broader kind of PyData and other open source tools for data science communities. So at the core of much of 2I2C is going to be JupyterHub, which is the sort of linchpin that ties everything together and orchestrates those interactive computing environments. But we'll also offer a variety of other tools in the open source ecosystem, really anything that supports interactive computing and data science, but importantly, only tools that are entirely open source, only tools that we can also contribute back to ourselves, and that, again, maximize the ability of educational institutions to choose where they want their workflows to be. So we want institutions of research and education to have access to these deployments using any open source language, using a variety of open source interfaces, basically any interface that can be served via your browser. We want to be able to support. We also want to support a variety of software and more kind of domain or community specific tooling through these deployments. In order to provide access to a variety of computing resources. So whether that be a highly scalable Dask cluster that can parallelize computations in the cloud, or a relatively modest set of computational infrastructure, but that just needs to be running 24/7 for, say, a 200-person course at a university. We also want to find ways to connect this infrastructure with particular use cases in research and education. So for example, in an educational context, you need things like grading infrastructure. You need things like a textbook. So how can we interweave these open source tools with those kinds of more specific pieces that you might need in an educational or a research context? And then, as I mentioned before, at the center of a lot of these things is going to be JupyterHub, which is the piece that helps manage all of these different pieces of infrastructure. It's kind of like a glue technology that brings everything together. So our vision is to have a flexible and large number of JupyterHub deployments, perhaps one for an institution or a few for a couple of departments inside of an institution at a website like myjupyterhub.2i2c.cloud or myjupyterhub.youruniversity.edu. And we want those JupyterHubs to hit the right balance between being powerful and heavily customized in a way that makes sense for the research and educational community, but that are also generic enough that we can scale them and deploy them for different kinds of use cases so that we can make this a sustainable model that allows us to generate revenue via these customized hosted deployments and allows 2i2c to both grow and accomplish its mission in giving back to the open source community. So you might ask, why should we use an open source stack like this? I've kind of taken it as an assumption that open source is the way to go, that open infrastructure is the way to go. But ultimately, there are really concrete reasons for why I think this is the right stack for the research and education community. For one, it provides, in my opinion, the best research environment for the best environment for research, the best environment for education, and the best environment for collaboration. As I mentioned before, the open PyData stack has become the de facto standard across this community. And I think that using open tools and open standards that are entirely vendor and stakeholder agnostic, like the Jupyter ecosystem, is also something that has proven to be very powerful and that both grows and remains over time. So using this ecosystem and providing it to institutions of research and education, I think will also be the right decision for them in the long term. To make sure that they are preparing their students, preparing their researchers, doing their work with tools that are still going to be around in 5, 10, 15, 20 years. But we also think that it's really important and worth highlighting that research institutions and educational institutions need freedom to run their workflows on a variety of infrastructure, whether that's on-premises infrastructure or cloud infrastructure on whatever vendor they want to. And in order to do that, you need to use technology that is openly governed, that has minimal assumptions about the kinds of cloud infrastructure that it's running on, and it uses entirely open source technology and tools. And this allows you to avoid vendor lock-in, which is something that at an institutional level is a real challenge in the research and educational community. And we have a long history of making suboptimal decisions that we end up regretting later on. So we think that 2i2c and this infrastructure stack can be a part of avoiding those challenges in the future so that we ensure that the research and education community is in the best position to succeed and thrive in the future. Okay, so with all of that, that's kind of the vision and the hope for what we want 2i2c to do. So where is 2i2c now, and how could others get involved and help out in the project if you're interested? So as I mentioned before, 2i2c is currently in the bootstrap phase. And by that, what I mean is we've recently set up the organization, so it now exists, which is a good first step. And what we'd like to do is run pilot Jupyter hubs for partners in research and education so that we can understand the kinds of challenges that exist across the variety of stakeholders in this space, both figure out how the infrastructure can be best customized and deployed to meet those use cases, but also so that we can explore models for sustaining these kinds of partnerships and collaborations moving forward. So eventually we want to get to the point where a researcher at a university or an institutional administrator can just ring up 2I2C or go to a website and pay for this entirely vendor agnostic open source infrastructure that their community can then use. And figuring out the right pattern for that is going to require experimentation and kind of early pilot stage partnerships, which is something that we're pursuing right now. In order to do all of that, we're also looking to find bootstrap funding, either from foundational partners or through collaborations in research and education. And we want to find people that are interested in deploying this infrastructure, deploying cloud infrastructure and this kind of open source data science stack explicitly in the ecosystem for research and education. So in general, we're in an early growth phase. We have a lot of interesting leads and obviously a lot of ideas and opinions about how this stack can be used to help research and education. And we think that there's a lot of great progress to be made in the coming months. So if you're a user at a university or an administrator or a scientist at a research institution, and you're interested in getting something like Pangeo for your community, these kind of customized cloud environments that provide collaborative remote access to data sets or compute resources or interactive computing environments, then reach out and we'd love to chat with you about ways that this infrastructure stack could serve you. At the same time, if you're at an institute of learning and education, if you're an instructor, or if you're an administrator who's overseeing educational infrastructure for your department, and you'd like something like the UC Berkeley Data Hub that provides these shared collaborative spaces for course content and course grading and tests and quizzes, as well as student collaboration, we'd also love to find ways that this 2I2C infrastructure can support your use case as well. And finally, if you think you have a more bespoke project in either research or education that requires more deep development and growth in the open source technology itself, these are also the kinds of projects that we find really exciting to find new ways in which the technology can serve use cases in research education. So again, please reach out. Finally, if you're just interested in supporting open source communities and you'd like to fund or support an organization that provides development and support for those communities, it's also something that 2I2C wants to be able to do to make it easier for organizations to support open source via the work that we do. So if you're interested about any of these ideas, if you want to talk more, or if you'd like to provide feedback about ways in which you think 2I2C could be helpful for you in accomplishing your own mission in research and education, you can get in touch with us at 2i2c.org #contact. Right now, we've got kind of like a waiting list of interested parties who we're going to send updates to via email as 2I2C grows and evolves and begins to offer more kinds of services and opportunities for collaboration. But we would love to hear your feedback. We'd love to hear how you think a nonprofit like 2I2C could better serve these communities. And we're excited to see what the next couple of months and years bring. So thanks very much for your time, and I look forward to following up later on.